Welcome to Glad Labs podcast. Today's episode, AI doesn't fix weak engineering. It just speeds it up. The hype surrounding artificial intelligence, particularly generative AI, is currently immense. Many in the technology sector are predicting a revolution in software development, with AI automating tasks that previously demanded significant human effort. However, a crucial point is often overlooked. AI doesn't fix weak engineering. It simply speeds it up. This isn't to suggest that AI is ineffective. It's a powerful tool, but like any tool, its success depends entirely on the skill of the user. A poorly maintained chainsaw will only make a messy job faster. It won't magically turn a beginner into a skilled lumberjack. Similarly, AI coding assistants like GitHub Copilot or Amazon Code Whisperer can generate code snippets, but they can't compensate for a lack of understanding of fundamental principles, architectural patterns, or testing methodologies. In fact, over-reliance on these tools can create a false sense of competence, masking underlying weaknesses in a team's engineering practices. Organizations with established, robust processes are the ones benefiting most from AI integration. These teams can use AI to automate repetitive tasks, allowing engineers to concentrate on more complex problem-solving. However, teams lacking these foundations often find themselves overwhelmed, struggling to validate AI-generated code and fix the resulting issues. The speed at which AI can generate code also means errors can spread much faster, leading to a significant increase in technical debt. Consider a scenario where a junior engineer is tasked with implementing a new feature. Without a strong understanding of data structures, algorithms, and design patterns, they might lean heavily on AI to generate the core logic. The AI might produce functional code, but it could be inefficient, poorly documented, and difficult to maintain. If the engineer lacks the expertise to critically evaluate the code, they might accept it as is, potentially creating a performance bottleneck and increasing the long-term cost of ownership. This illustrates how AI can expose, rather than resolve, fundamental weaknesses. The issue goes beyond individual code snippets. Architectural decisions, database schema design, and system integration all require careful consideration and a deep understanding of trade-offs. AI can offer suggestions, but it can't make informed decisions on behalf of the engineering team. Blindly accepting AI-generated architectural diagrams or database schemas can lead to scalability problems, security vulnerabilities, and integration difficulties. The rapid pace of AI development can also discourage thorough testing. It's tempting to skip unit tests, integration tests, and end-to-end tests when AI is generating code quickly. However, this shortcut inevitably leads to bugs and regressions, eroding user trust and increasing maintenance costs. As one report points out, the focus should be on understanding the reasoning behind the code, not just accepting the output. The most significant shift required isn't simply adopting AI tools, but cultivating a culture of critical thinking and continuous learning. Engineers need to move beyond being mere code writers and become problem solvers, system architects, and quality advocates. This demands a renewed emphasis on fundamental skills. Understanding algorithm analysis, the time and space complexity of different algorithms, is crucial for evaluating the efficiency of AI-generated code. Recognizing and applying appropriate design patterns ensures code is maintainable, scalable, and reusable. Mastering various testing techniques, from unit testing to performance testing, is essential for ensuring code quality. And understanding how different components of a system interact is critical for designing robust and scalable applications. Rigorous code review, even for AI-generated code, is also essential for identifying potential issues and ensuring adherence to coding standards. Engineers should view AI as a powerful assistant, not a replacement for their own expertise. The goal isn't to have AI write all the code, but to use it to enhance their abilities, automate tedious tasks, and free up time for more creative and strategic work. This is where understanding what comes next is critical. AI can help you reach a solution, but a skilled engineer understands how to iterate on that solution and prepare for future requirements. It's also important to remember that AI models are trained on existing codebases, which may contain biases, vulnerabilities, and outdated practices. Accepting AI-generated code without critical evaluation can perpetuate these issues, potentially introducing security risks or technical debt. Therefore, a solid understanding of security principles and best practices is more important than ever. Many organizations are now focusing on tools that help them analyze AI-generated code for potential vulnerabilities and compliance issues. The current landscape suggests a growing demand for engineers who possess a broad range of skills and a deep understanding of fundamental principles. This isn't a return to the jack-of-all-trades model, but rather a recognition that AI requires a more holistic approach to software development. Engineers who can effectively leverage AI need to be able to clearly define the problem they're trying to solve, develop a well-defined architecture and data model before engaging with AI, critically assess the AI-generated code for correctness, efficiency, and security, seamlessly integrate the code into the existing system, thoroughly test its functionality, and continuously monitor the system's performance and make necessary adjustments. This type of engineer, the full-stack fundamentalist, is becoming increasingly valuable in the AI era. They aren't afraid to get their hands dirty with low-level details, but they also understand the big picture and can leverage AI to accelerate their work. This is supported by observations that AI hasn't yet helped most engineers, suggesting that the benefits are disproportionately realized by those with already strong foundations. Don't fall into the trap of believing that AI can solve all your engineering problems. Instead, focus on strengthening your fundamental skills and building a robust engineering culture. You can do this by investing in training for your team, prioritizing code review, embracing continuous learning, refactoring existing code to improve quality and maintainability, and experimenting with AI responsibly, always prioritizing understanding and validation over speed. Consider exploring tools like CAD Query to deepen your understanding of underlying principles. AI is a powerful force, but it's not a magic bullet. It's a tool that can amplify your strengths and expose your weaknesses. By focusing on building a solid engineering foundation, you can harness the power of AI to achieve truly remarkable results. Thanks for listening to GLAD Labs podcast. Visit gladlabs.io for more episodes, articles, and insights.
See you next time.